Hello again to my YouTube channel. Today I will continue to show you the technique that one can use to find in the best parameter of our model. So as we know, when we try to apply some models, that's not enough to give me the performance of my model. For this reason, I need some techniques to help me to find the best parameters for our model. Well, in two last sessions, we discussed in logistic regression as example of algorithms, and I show what is the math behind the logistic regression, what is the metrics to measure the performance of our model, what is the metrics we use to measure the performance of our models. In this case, I mean logistic regression. Today, I will show you um, how we can using one of techniques called cross validation. Well, the cross validation totally is a technique help us to find the best parameters. Well, of course, in cross validation we have a types. Okay. Well, let's take an example here. Okay. We consider a data set with 1,000 data point. Okay. If we have in this example 1,000 data point, how we can split in my data. So here we have 70% of my data is just for training and 30% for testing. Well, in this training also, I take in 80% of the 70% just for training and 20% of the 70% is for validation. That means I need to find the best parameter or parameter tuning. Well, here when taking this random state, this attribute of random state, if I assign it value for this random state each time, I will get the accuracy different. Okay, maybe it will be increase or maybe can decrease. That's different. So we get in different accuracy because we're changing the random state value. Because here in this attribute, when we split in the data, so we are assigning a value for this random state. Okay, for this reason, this cross validation is coming here. So when taking this part of training data and here in this parameter of CV or cross validation, I give for this attribute 5. What does that mean? Does mean simply I divided my dataset for times part. So in this example or in the first part, I train my data, okay, and I validate 20% of that, then I get the accuracy. I come in again with the new set, I train, I validate, and I get accuracy. And I go just at the end. Well, in the last or in the end, I get the mean of all accuracy. I take in accuracy 1 plus accuracy 2 plus accuracy 3, 4, 5, dividing by 5, then at this time we get my mean accuracy. Okay, I get my mean accuracy. Well, here this is the idea behind this cross validation. Well, as I did before in this cross validation, we have types. Okay, let's check in or see the first type. So the first type of cross validation is that's called leave one out of cross validation. Leave one out of cross validation. So here, if we consider this example of 500 point, okay. Well, the training data, this is the training data, 500 point. At this time, I take in just 1 point here for validation, and the rest is for training. That means 499 is for training. At this time, when I taking this 599 for training and I taking just 1 point here for validation, I get this accuracy. And I go again for a new one. That's mean here one, I take in two for validation and I take in 498 for training plus one for training and two for validation. And I still continue at the ending of all these data points we have here. Okay, that's mean I will check or validate each point of all these data sets. At the end, what I do, I sum all this accuracy and I average it. Okay, I want to find the average of all my accuracy, all the accuracies I find. But for this type, let me leave one of cross validation. The first type has some disadvantage. One of disadvantage of this method is the time complexity. Time complexity will be huge. That means if we have maybe 10,000 point or more than that, 1,000, 100,000 point and apply this method, that means that the time complexity will be huge. That means I need much of time to check each point of all this simple or the data set we have. And the second advantage of this method is go to overfit. That means we have or we can facing the problem of overfitting. Why? Because the training of data or the error will be zero or very close to zero. This means the error it will be close to zero. That means my model it will be capture all the variation I have around this training data set. At this time, if the new point is coming to my model, it will be less or the accuracy of prediction based or compared to the training one, it will be less. That means I face the overfitting problem. Okay, so we have the second type of this cross validation. It's leave p out of cross validation. We have just one parameters called p. Okay, well in this in this parameter I will assign values. Okay, 10, 20, 30. That's depend. So it will be considered like list of values. At this time I will check all these values to find the best one. So we have just one parameter in this type here. And the third type is k-fold cross validation. Okay, k-fold cross validation. So if we consider 500 point of my data set, the validation data size, does mean what is the size of my validation data? It will be 100. How we do that? We take in the number of my data set I have divided by the number of k. In our case, we have 5. That's mean 500 divided by 5. Okay, at this time I will get 100. So what does mean? So does mean if in my first experiment I take in just 100 point for validation and the rest for training. The rest in our cases will be 500. So 500 for training and 100 just for a validation. And I continue in this process. I find my accuracy and I pass to the second experiment. I have here 100 point. Okay, I have here 200 and also here 200 for. So both of the side right and left is for training and the middle point is for validation. And I get my accuracy. And I still continue. And here I have 500 for 500 for training and just 100 for validation. So here we have 5 experiments. K in this case I assign K 5. That means I have 5 experiments. 500. That means each 100 for this 500, it will be validate with my algorithm. At the end, I sum all the averages I get here, and I average it. Okay, I sum all these accuracy we have here, accuracies here, and average it in the end. Okay, so this is for fault validation. Okay, fault cross validation. So we have also this fourth fourth type in this CV or cross validation is straight key fault cross validation. So this technique is used when we have imbalanced data set, and especially we use it when we have a classification problem. So when we facing the problem of imbalanced data, so in this example here, just if we consider this 500 point here with two categories, category 1 350 and 0 category we have 160 point. Okay, that means we have imbalanced data here. At this time when we're using this street file default validation, if I assign the key equal to 5, this means I divided 500 by 5 and I get 100. So here 100 point use it for validation and the rest for training. So the same process of k-fold validation. The simple difference here is in this case of straight fault, we use it when we have the imbalanced data set. Okay, so I continue in the same process. At the end, I average my accuracy. Well, for all these types here, we need some method or we need approach give us the ability to do if each combination possible to find the parameters. So I will show you now how that is important. Well, the hyperparameter tuning with cross validation does mean hyperparameter does mean I want to find the best combination of my parameters with cross validation. So finding the best parameters so while training the models. So we have this grid search. Grid search, when I call this grid search, does mean we have grid search plus cross validation. So this technique of finding the optimal or the best parameter value from given set of parameters. So in grid search, we have some methods here. We have some penalty. You have L1, L2, elastic net, and none. Inside of these methods or these penalties, we have some solvers. We have some algorithms of optimization. Can found LBFX, linear, linear, or Newton CG, or Saga, or Newton glossary. That's depend, of course. So at this time, what is the idea behind this grid or this grid search is to combine. For example, I can use these algorithms with this L1 with something, and I will also use this linear or Saga. I will use all the combination. Okay, the combination of all these things. Those combination can give me the best parameter. Okay, grid search making sure that go ahead and check in every combination. Try to find the best out of combination with high or best accuracy. That's I did before. So with this grid search, I try to find the best combination to finding the best result. Okay, let's assume that so for L1 and LFP is the best parameter for logistic regression. So in our case, we discussed before in logistic regression, and here the best we can use here is L1. L1 norm plus mean. We have uh, lambda times the sum of all the elements slope squared. This first, this is L1 for uh, sorry, we using this we have this alpha times a go from 1 to n, absolute value for slope. This slope, that means I try to find or feature selection. I want to select the I want to select the best feature. Okay, and also I use this Shannon algorithm here for optimization. So when we use this LB phase, that means I want to use it in gradient descent to find the best parameter in case of logistic regression. Okay, when apply this L1 and LFPG inside of logistic regression, that means so we have part of my dataset for validation and the other part for training, and I find accuracy. I still continue in this process. In the end, I average all my accuracies. Okay, so of course we have disadvantage. Each algorithm of we use it here, each algorithm we use here is has this advantage. So the advantage of this is the time complexity increase with a huge dataset for training my model. That means if we have just 20,000 dataset, so the time I need to train this dataset is not the time I need another dataset, for example, 100,000. So the time is changed. That means the dataset here is increased. That means the time also it will be increased. Okay, that's what's called time complexity. Well, we have another approach here. It's a random search CSV. A random search here. So randomly we select the best set of parameters. Okay, randomly. So randomness. Random use it here to apply or to select the best set of parameters. So example here, if you use it 10 iteration with CSV of 5, that means cross validation is 5 and the number of iteration is 10. 10 different combinations, that means 10 iteration, this 10 different combination I need plus cross validation. That means 5 times 10 is equal to 50. I need in total 50 possibilities or 50 combination to find the best to select the best parameter. So the advantage of this method is the complexity is decreased because I use the randomness, the approach of randomness. It selected just some six. Okay. In this case, if we have 10, it will be 50. If we have, for example, 50, it will be 15 times 5. It will be 75 possibilities. At this time, we decrease the complexity of time. Well, at here I will end in my session. I hope that's clear for you. So I will see you in the next sessions to show you how we can implement all these things. Okay, because that is very important to understand it and to have an idea about all these things how it works. Of course, it's easy to implement it in Python or Scala or whatever, but the important idea is to understand all these things how it works. Okay. Well, happy learning again for everyone. I see you again. Bye bye.